Hello student, in this video I am going to start from the last topic we are discussing about forecasting methods. So we are here in this slide uh, discussing about forecasting periods 7 and 8 depending upon the value of previous periods like 1, 2, 3, 4, 5, 6, 7. The values for those periods, actual values are here. So we are going to forecast like using moving average or weighted moving average for 2 period moving average or 4 period moving average or 2 period weighted moving average, where T1 means one cycle will get weightage 0.6 and one cycle will get weightage 0.4, and again exponential smoothing with alpha 0.2, the period 6 forecast being 375. That is the exponential smoothing in case of exponential smoothing. Here you can see we use alpha. We need the last period's forecast, okay, and we need the last period's actual value, okay, and those value against alpha. So we have those things, last period forecasted thing and actual value will be calculated. This is the actual value and forecast value need to be calculated. So the equation for moving average is this one. Actual values they have n. So in case of this equation also for 2 period moving average, we need to suppose for one moving average will be directly 300 because there is no period beyond that before this 2 period. So in case of this 1 moving average will be 300 plus 315 divided by 2 period divided by 2, and then this for third period, what is the moving average? That is 315 plus 290 by 2, that is the moving average. So in that we need to calculate out, and then also 4 period will be by calculating 4 period as a whole or whatever the period we have till then. So for 1 300 per, for this one 300 plus 315 by 2, and this one 3 actual values there by 3 and 4 actual values there by 4, in that way. And then in case of 5 we plus this one up, then divided by this. So in that way we have to go for 8. So you can see here by having those things, if you calculate 300 by 315 is almost here will be 3 almost like 307. So again 7.5. Again for this 1 this will be almost like 3 this is 10 25 20 12.5 12.5 1302.5 almost. Then because if we plus this 2 divided by 2, then it will be this one, then this 1 that is almost will be 2 17.5 and 317.5. So again this 2 will be almost 332.5, okay, and this 2 almost 340 will be there. That is 340, okay, that is 340 value, okay. It is actually I'm writing here, it should be here, and again 360 and 375 average will be this one. So actually I have misplaced these values, that is a 340 for 320 360 divided by 2 340. And again in case of 4 period, if you plus this 4, if you plus this 4 or if you plus this 4 first, then you will get this average, okay, and if you include this one you will get this average, this 4 period moving average. And in case of 2 period weighted average, then you have to multiply you have to multiply this with 0.6. 2 period means if you multiply this with 0.6 and this with 0.4, that is what it's saying in the previous slide, that is 0.6 and 0.4. so you have to multiply this 0.6 and 0.4 plus, then divided by 2. That is the weighted moving average. That is the weighted moving average. Summation of CT into AT. CT is there in this equation, 0.6 and 0.4. So if you multiply this with this 2, then whatever you summed up, that value will be this one. So in that way you will get the 2 period weighted average. Then for exponential smoothing you need these values, where this is the equation. Alpha is given here 0.2, okay, 0.2, and then 80 is the actual value. Actual value is this 375 in case of, if we are going to find out the value of 8. In case of 7, you need to use the value of 360, that is the actual value. And what is the forecasted value? You need to, that is the 1 minus alpha last period forecasted value. So you need to use, so suppose if you are going to calculate this one, you need to use this one, last one forecasted value, and the actual value is this one. So those values need to be used in this equation, and the value of alpha is 0.2. so that in that way you need to find the exponential smoothing. So try to complete this table as per I have discussed right now. So again, forecasting a trend problem, a company uses exponential smoothing with trend to forecast uses of its lawn care products. At the end of the July, company wishes to forecast sales for August. July demand was 62. The trend through June has been 15 additional gallons of product sold per month. Average sales have been 57 gallons per month. The company uses alpha 0.2 and beta 0.10 forecast for August. So smooth the level of the series, that is here alpha is given 0.2 and 80 is the demand was, actual demand is 62 and here this 1 minus alpha into the predicted one. How can we find the predicted one? As t minus 1, that is average value 57 per month, okay, plus 50, so trend is 15. So our predicted value here in this case, so because the equation of smoothing is that for July you can use like this one, alpha a plus 1 minus alpha into, this is the predicted, this should be the forecasted value, and in here forecasted value can be calculated using the actual average sales, that is 57 plus what is the trending, so 57 plus 15. So here average sales has been 57 gallons per month, plus trend means we need additional 50 gallons per month, that is a trend. So 57 plus 15, that is the predicted value. So if you multiply this, then you can get 70. So what is the smooth, what is the trending smooth? So for July you need to use the beta value here, so here you can see B into ST minus S1. ST means what is for July, it is 70. What is previously, that is 57. So 70 minus 53, and that is then into beta, that is smooth the trend. So we need to smooth the trend. Then 1 minus B, that is opposite of B, complement of B into average. We need to smooth the average, or we can say trend. So 70 minus 15 into 0.1, because it is given beta, and into 0.9 into 15. So we are multiplying the, we are multiplying the average. So that average is actually gonna change here 14.8. So we are actually smoothing that average value, that is 14.8, and this value is actually we are smoothing the level of the series. Means though we are getting 57 or 62, demand is 62, though we are adding this 15, but actually our need or our smooth after smoothing the need might be in around 70. So that need is 70 and smoothing of average is 14.8, and when you sum up that thing, there is a forecast including the trend. So that is the ultimate forecasting value for the August. So try to understand this one. If you find confused, please let me know. Again, I'll give some explanation if you have some problem with this to understand. Linear trend line, a time series technique that computes a forecast with trend by drawing a straight line through a set of data using this formula. So obviously this is the equation of line where y equal to forecast for period x, where y is forecast for a period of x. X is the number of times period from x equal to 0. A is the value, or A here is taken as big but it might be small also. Same case, A is the value of y at x equal to 0, that is y intercept. B is the slope of the line. This is a simple equation of line. So actually linear trending line, a time series technique that computes a forecast with trend by drawing a straight line through a set of data using this formula, like the regression. So here basic forecasting models for trends compensate for the lagging that would otherwise occur. One model, that is trend adjusted exponential smoothing, uses a three-step process. First this one, second this one, third this one. So that actually this problem has been detailed here if you go through it. So first step is that you need to smooth the level of the series. Then second step is that you need to smooth the trend. So here that is trend adjusted exponential smoothing. So in the previous the tabulated equation, we are going through that exponential smoothing case, and you have found this equation previously, but in this side this was written as a predicted one, or predicted or forecasted value. So that forecasted value is here is expanded by using this one, where S is the smoothing value, okay, at that time t. So that time is calculated by using the value of previous values. So that is about smoothing the actual value, or we can say and then by using exponential smoothing, and then we are using smoothing the trend, mean we are using the smoothing the actual trend in rise in both positive or negative way. Then we try to forecast including the trend, that is this is the actual forecasting value with the trend that will be summed up. So we can calculate the average demand per season. So average, suppose we want to calculate some averages demand per season, there might be different demand for different seasons, so we can also calculate that. Or we can calculate seasonal index for each season of each year. It might be like look like we are putting some, or we are trying to find out some weighted index for a specific season. Divide the actual demand for each season by the average demand per season for that year. Average the indexes by season. So how we can go for forecasting the seasonality? First we need to calculate the average demand per season. We need to calculate the average demand per season, or we can go like this, average quarterly demand. Then calculate the seasonal index for each season of this year. There might be one for July to October, then again November to December, and the index is 4, like that. So calculate the seasonal index that might be different for different part of the year. For each season of the each season of each year, divide the actual demand, whatever demand we are getting, this is the average demand, this is the actual demand for each season, by the average demand. Whatever average demand we are getting here, and what is the actual demand, we need to divide the actual demand by the average demand. by the average demand per season for that year. Average the indexes by season. Take the average of all spring indexes, then of all summer indexes. So in that way, forecast demand for next year and divide by number of seasons. Use regular forecasting method and divide 4 for average quarterly demand. Then multiply next year's average seasonal demand by each average seasonal index. Result is a forecast of demand for each season of next year. So we'll try to go through this again this problem in the next class. Okay. Till then, try to go through the content again. It might be specifically this part, because this is important in case of you are going to understand about forecasting the seasonality value. But also if you try to go through this one, forecasting the trend, that is can be understand using this equation or this problem. So if you find any problem regarding this content of this video, please let me know. We'll try to resolve that over Google Meet. Thank you.